Good morning, everyone. Good morning. Hope all is well. Somebody say something? Thought I heard something.
Oh, no, I just said good morning.
Oh, good morning. Good morning. Appreciate it. Appreciate it. Let's see. So I think last class we stopped at volume. So this is still section. Hold on 1 second. I'm trying to pull it up. Make sure we got it. Of course. There we go. So this is still section 7.2. But we did perimeter area last class. And we're going to finish off 7.2 with volume. All right. So let's finish this section. So finding volume is the same thing as finding your area. You need the formula, and then you need to plug in your values accordingly. And also you need to make sure you remember that each shape has its own formula. So you can't just frivolously just be using formulas any old kind of way. So you have to know the shape and then know the formula that corresponds to that shape. So here we have the radius of the base of a cone is 8 centimeters. The height of the cone is 12 centimeters. So the purple box, that's the volume of a cone. That's how you calculate the volume of a cone. 1/3 pi r squared h. So they tell us our radius, our r is 8, and our height is 12. Our h is 12. So I plug them in accordingly right here. Now, if you were just doing this in the calculator, you can just throw this in the calculator and get it. But if they want exact, then you do want to simplify as much as possible with pi still there. So notice what I did here is I went ahead and divided the 3 into 12. And that gave me 4. Then I had 8 squared, so that's 64. Then 64 times 4 is 256. So in the purple box right here, that is your exact answer. The 256 with pi still involved. So 256 pi is your exact. And then go ahead and calculate with pi, and that'll give you your approximation. Then you'll be able to find your approximation by rounding it to however many decimal places they ask. So make sure you pay attention to that. They could say 1 decimal place, 2 places, or 3 places, but they expect you to hold true to whatever their directions say. All right, questions on that one before we do another one? All right, scrolling up. Let me know if I scroll up too far. All right, so next one, they don't give us any words, they just give us the shape. This is a cylinder. So we want the volume of a cylinder formula, and that's this right here. Notice we need the radius and the height in order to be able to plug in. That's just pi r squared h. Now, our height is 4 meters. But remember, we talked about last class that if the line goes from end to end in your circle going through the center, that's your diameter. Your radius goes from the center to the end, you know, if you're doing it that way. So we need to make sure we have the radius versus having the diameter. So you take half of your diameter, and that'll give you 3. That'll be your radius. So if you go back to the last one we had, notice it goes from center to end. that's your radius. But if it goes from end to end or point to point, so I should say points, not ends, but center to point. But if it goes from point to point, then that's your diameter. So you have to take half of that to get your radius. So that's why we have 3 right here.
So the formula for the cylinder is in green?
Yes.
Okay.
Yep. Pi r squared h. I was waiting for everybody, make sure everybody was done with that last one before I scrolled all the way up. So yep, that is your formula right there. And then you plug in accordingly. Our radius is 3, height is 4. So 3 squared would be 9. 9 times 4 is 36. So that 36 pi is your exact. And then go ahead and do 36 times pi in your calculator and round that however many decimal places they ask for. And also don't forget, I didn't point it out in the last one, your measurement cubed. Remember we talked about that last class. Volume is always going to end in cube, your cubed measurement. All right, scrolling up a little. No, y'all don't need that. Hold on, let me see if you guys are doing slant height. I mean slant, not slant, surface area. Let me see if you guys are doing surface area. I think we are good, but let me make sure. See volume. Okay, yeah. Very good. Let's scroll up. Okay. So questions on volume before we go to the next thing. Once again, it's just like the area. You find the formula that corresponds to that shape and plug in the dimensions accordingly. And simplify. All right.
And the exact has pi always in the answer, correct?
Yes. It doesn't become an approximation until you calculate with pi, and then it becomes a decimal, and then you round to however many decimals the directions tell you to.
Doesn't it seem backwards?
Well, it depends, because the way that the reason why they call it exact is because pi is a run-on decimal. And so,
okay.
Yeah, and so if you leave pi there, then that means if I give you 36 pi, I give you the right to round 36 pi to whatever you want to round it to. But if I give you 113.1, you don't have no choice. It's already rounded, it's already approximate. So that's why when you leave pi there, that's considered exact, because I'm giving you the right to have the exact value and what it's worth, because pi is not 3.14, it's 3.1415, blah, 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 blah. So that's the exact value for it. And then from there, once you remove the symbol and replace it with whatever number you replace it, from that point forward, it will be an approximation. So Yeah. I can see
Okay,
why.
thank you.
Yeah, yeah, no problem. And but trust me, I can see why it can seem backwards, but you just got to go a little deeper with it. You know what I mean? Yeah. All right. So let me show you guys this before we do the next topic. Now, one's interested. Okay. So next thing is 7.3, 7.4, 7.5. Notice 7.3 is linear measurement, 7.4 weight and mass, and then 7.5 is capacity. So when you looking at all three of these, then you're talking about converting measurements. All of those work the same way. So when we talk about them, we're going to talk about them all at one time. They separate them as different assignments, but the operation and what you would do, the way you convert is going to be the same thing. Basically, what dictates it is, are you using US measurement versus metric? The fact that you're doing linear versus mass versus capacity doesn't change anything. So we're going to talk about all three of those conversions and how you would convert together. And it's really not as long of a topic as it may seem. So we're looking at let's say we said that's 7, 1, 2. Oh, let me do this. Let me go back to our class. So we are about to look at these three right here. So if you want to copy down the titles, we'll say, the other section for later, but we're looking at these three sections right here. Linear measurement is 7.3, weight and mass 7.4, then capacity 7.5. So we're going to reference meters, grams, and liters when we get in there, but notice the meters measurement is 7.3 grams, mass is 7.4, liters, it's going to be 7.5, your capacity. Matter of fact, let me look at something else where you guys are doing that. Yep, same thing. Yep. All right. So let's go to all right. So of course, don't worry about the 7.1. That's not for us. So we're gonna look at US measurement first. So if you're doing US measurement, it's called US measurement because for the most part, the US are the only ones holding on to these conversion factors. Most of the world uses the metric system. And we're going to look at that in a second. But when you talk about US measurement, there are these conversion factors, whether it's, like I said, whether it's length, mass, or it is your capacity, quarts, pints, and all the stuff like that. You have these metrics, these conversion factors, not metrics, but these conversion factors that you will lean on in order to be able to convert. So these first few of them, 12 inches equal to 1 foot, 3 feet is equal to 1 yard, 36 inches equal to 1 yard, and 5,280 feet is equal to 1 mile. And I need to send conversion factors. Matter of fact, let me put it in my phone. Send you guys those conversion factors that oh, come on. And then all right, so just remind myself to send that to you guys. So these conversion factors don't change. You can find them anywhere.
Mr. Tucker, can I get with you after class?
Yep.
Okay.
All right. So these conversion factors don't change. They're the same no matter where you go. So it's not like I'm going to be sending you something magical, but it just, was requested. So I'm going to send it to you anyway. So I don't have a problem doing that at all. But if you go to Google, Siri, Alexa, whatever, or you could just go to the book, these conversion factors will be the same. So you have an option of how you would use these. Either, let's look at the first one. So I said something in the chat. Oh yeah, no problem at all. So let's look at 12 inches equal to 1 foot. I can either use that as 12 inches over 1 foot, or I can use it as 1 foot over 12 inches. So what will dictate how I use it will be the problem that I'm initially given. So let me erase some of this stuff. All right. So you're starting off with 18 inches and you want to convert that to feet. All right. So if you want to do that, then of course you're going to go to the conversion factor that deals with feet and inches. All right. So 12 inches equal to 1 foot. All right. So now what will dictate how I use my conversion factor is where I'm starting with. If I'm starting with inches, then I want inches to be down here. And that's always going to be the case. Whatever you start off with, you want that to be in the denominator of the next fraction. All right. So that means I will be using this conversion factor right here. So that would be 12 inches down here and 1 foot right here. So now what that allows to happen is just like with fractions. You know, if I have 4/6, 4 is 2 times 2, 6 is 2 times 3. The 2's cancel because I have a 2 in the top and the bottom, and that leaves me with 2/3. So that's the idea that we're coming across or coming with. If I have inches initially, then I need inches down here so that they can cancel out. And then notice that will leave me with the feet measurement, which is what I was trying to convert to anyway. All right, so now if I multiply across, I have 18 over 12 feet. Then I can convert that to a fraction. I mean, convert that to a decimal or leave it in fractional form, doesn't matter. And in green, I showed the way you would leave it in fractional form. But either way, though, either answer would be correct. But now you're in feet, and that's what you need. All right, questions on that before we look at another one? All right, so everybody good before we do another one? All right, so the next one, 14 feet to yards. So the conversion factor here would be 3 feet is equal to 1 yard. All right, so let me erase this. So notice what I have here. You start off with 14 feet over 1. I need feet. Oh, still have my eraser on. I need feet to be down here. So that's why I have 1 yard over 3 feet. My feet cancel. And now I can multiply across. That leaves me in yards because that's what I needed. So that's 14 over 3 yards. And of course, you know, however many decimal places they want, that's what you would adhere to. Sorry about that. Sorry about that. Is everybody okay with this one before we go to the next one? All right. So next one, 3.5 tons to pounds. All right, so there are 2,000 pounds and 1 ton. So once again, got to make sure you have the right conversion factor. Initially, I didn't give you this one, but it's out there. So you would look, you can always Google how many tons are in a pound or how many pounds are in a ton. So there's 2,000 pounds in a ton. What I decided to do was take this 3.5, which is what we started off with, 3.5 tons, and just convert it to a fraction, because that's what we're doing anyway, write them as fractions. So taking that 3.5 and writing it as an improper fraction, 3 times 2 plus 1, and then place it over that 2. So I completely understand. Thank you for letting me know. All right. So 3 times 2 plus 1 gives me 7/2 tons. So we're still in tons. I haven't converted anything to pounds yet. Yeah. Not a problem. So now we have 7/2 tons, 7.5 tons. No, it's not 7 halves. 7/2. I'll just leave it like that, right? And then I would do 2,000 pounds over 1 ton, because I need these tons to cancel out. Multiply across, it gives me 14,000 pounds over 2, which reduces to 7,000 pounds. All right. Questions on anything? Make sure we're okay. All right. Let's scroll up. So before I go to the metric system, all of these are handled the same way. I got, 1 or 2 more after we do the metric system to make sure we're okay, but they're handled the same way. Convert what you originally have to a solid fraction. Find the conversion factor, multiply accordingly. All right, make sure that if you start off with tons, you have tons down here so that they can cancel out. Notice that leaves us in pounds, which is what we want to be in. All of it is the same thing. So it doesn't matter if you're going from pints to quarts, if you're going from inches to feet, or whatever the conversion, tons to pounds, all of it is the same process. All right, so any questions on the process? You need to make sure that you find the conversion factor, then multiply accordingly, reduce and simplify. All right, so let's look at the metric system. Now the metric system goes off of prefixes. See if I can get this whole thing in here. All right, so these are the base prefixes. It can get very, very large. You got your phone, gigabytes, giga and mega, very, very large. And then it can get very, very small, pico, nano. You may have heard of nanotechnology, vaccine and stuff like that. So it can get very, very small, very, very large. But these are the base ones. Notice our base is in the middle. That represents 1. And there goes our letters that I told you we're going to be using in a second: grams, meters, liters. Those are the base. And then from there, notice we got deca, which goes 10, hecto, 100, then kilos, 1,000. Then deci, 1/10, centa, 1/100th, and then milli, 1/1000. All right, then you see our prefixes or abbreviations for those prefixes: KH, DA, DCM. All right. All right, let's scroll up. Is everybody okay? All right, so those bases, I already mentioned them before, but just making sure we have it written. So your grams is weight, G, meters is your length, M, and then liters, L, volume and capacity. All right, very good. Also in the purple, just showing you how we use this as far as notation is concerned. Those prefixes can go in front of either one of your bases. So if you're dealing with kilo, you can go kilogram, kilometers, or kiloliters. Or if it's centigram, centimeters, centiliters. So those prefixes, they go in front of our bases, depending on what you're measuring. All right. Very good. All right, so notice that these, now go back here, notice these have a certain order because of their value. And notice they're multiples of 10. So if you're talking about multiples of 10 mathematically, all you're doing is moving the decimal place to the right or to the left. So if you can remember the order, King Henry died by drinking chocolate milk will help you to remember the order. You know, K, representing kilo. I don't want this color. Might want to go green. K representing kilo, H hecto, what's hectare? D deca, B will be your basis. So either one of your bases, depending on what you're measuring. D is deci, C center, and then M is milli. So King Henry died by drinking chocolate milk. It is imperative that you hold true to the order because that's going to dictate how you move your decimal to the right and to the left. All right, let's scroll up. All right. So if we have 0.38 meters and we want to convert it to millimeters, so we're talking about this right here. We have 0.38 meters and we want to convert it to millimeters. So what you would do is find meters and figure out what millimeters is in relationship to it. So remember, you're holding true to King Henry died by drinking chocolate milk. And so your base is right here, meters, and you're gonna go 1, 2, 3 to the right. So take what you originally had, take the decimal and move it 3 to the right. That's what we did here. And that gives you 380 millimeters. So all you're doing is moving your decimal to the right or left according to the position that you start and where you're trying to go. All right, questions on what we did there? We're gonna do, of course, we're gonna do some more, we're gonna do some in each using each one of the bases, but it's the same process. All we're doing is moving the decimal to the right or left. And what dictates that is the prefix that we're starting with and what prefix we're trying to go to. All right, can we try another one? So this time we want to convert 12.9 centimeters to hectometers. So you start off in centimeters and you go 1, 2, 3, 4 spots to the left. I don't think I mentioned that last one. I don't know if you noticed that we put a 0 for a placeholder. I don't think I mentioned that, but yeah, you put a 0 for a placeholder because we went 3 to the right, but we only had 2 numbers. So that 0 as a placeholder was necessary. So you always put those there when you run out of digits. Same thing happens here. So we're going to move our decimal 4 places to the left. And that's what we did here, 4 to the left. And that took us 2 digits away from the 2 digits that we had. So we had to use 2 zeros for placeholders. So that's 0.00129. All right, so let's do something in grams. Once again, hold true to the process or the order of our metric system: kilograms, hectograms, decagrams, grams. Don't forget your base. Then we have decigrams, centigrams, and milligrams. So we have 4.23 decagrams, and we want to go to centigrams. So you start at decagrams and go 1, 2, 3 to the right. And that's what we did here. We have 4.23 and move the decimal 3 places to the right. Once again, holding true to the fact that if you move past the digits that you have, you need zeros as placeholders. So that'll be 4230 centigrams. Any questions? Sorry, I had people walking through the door. One of the challenges of teaching at home. All right, so let's try it again. So let's change it to liters. So if I have 1,579.64 milliliters and I want to convert it to hectoliters, once again, our positioning does not change. Kiloliters, hectoliters, deciliters, our base is liters. Then we go deciliters, centiliters, and then milliliters. We go on from milliliters to hectoliters. So we go milliliters and move 5 spaces to the left. Move decimal 5 places to the left. Still goes at least 1 digit further than what we originally had. So we need a 0 as a placeholder, and that's 0.0157964 hectoliters. Any problems? Any problems? All right, so that's the metric system. That doesn't change whether you, and that's why the whole word uses it, right? It doesn't change whether you are measuring capacity, liters, length, meters, or mass, grams. It's still the same process. So this is why I didn't want to lecture on 3 different sections, because it's still the same process and it will get redundant. So, as always, if you go in there and you try something out, it doesn't work, or it looks a little different than what we talked, bring it to class and we'll talk about it. It's no big deal. And we can walk through any problems that you guys have. So always feel free to bring in the class. All right. So now it is possible they could ask you to convert from US to metric, but then this falls back in line with what we were doing earlier, where you find your conversion factor, then use your fraction accordingly, and then multiply, simplify. So let's say if we were going 55 miles to kilometers. So miles is US, kilometers is metric. So the only time metric works is when you're staying in metric, when you're talking about just moving a decimal. But if you're going, across the US and everything like that, then you do have to use a conversion factor, and we have to lean on our fractions like we did previously or in the beginning of this section. So find like conversion factor from kilometers to miles or miles to kilometers. So there's 1.61 kilometers in is going to be equal to 1 mile. So then you go from 55 miles, write it as a fraction, just put it over 1. And notice we have our miles down bottom because we need them to cancel out for us. And then once that happens, we recognize we're in kilometers, so we're in a good place. Multiply across 55 times 1.61, 88.55. And that's our answer. Questions on that? Make sure we're okay. Everybody good? Everybody straight? All right, so now there's only one more section in this chapter. We could knock it out now, but I'm going to hold off and save it for next class. It's a light section too, just talking about converting temperature. But next class, I'm only going to do that section, so that leaves room for you to ask questions if something is generated over the weekend. This is considered 3 different sections right here, so you got 3 different homework. So like I said, I didn't want to just overdo it for no reason, not just because we can. You know what I mean? So I'm going to pull back as far as lecture. Not going to do the last section until next class. Once again, that will be the only section we do next class. So there will be room for you guys to have questions if you have them next class. And then we'll talk about how we're going to move forward with the rest of the content. All right. So any questions or anything before we close out today? I know I got to sit back for one of your classmates, but I don't think that's a class thing. I think that's an individual thing. So any questions class-wise on anything before we close out? Everybody good? Everybody straight?
I'm looking for the question so I can give it to you in the lab, but it's the linear equations using substitution.
Mm-hmm.
Yeah, I'm trying to find one that it takes me too long to do that. I must be doing something wrong.
Okay.
Okay.
Let me do this. For those of you who want to stay back and hear her question, feel free to do so. But if not, then that's it for class. Have a great weekend. Be safe, and I will see you next week. All right. So, Miss Wilhelmina, do you have one in particular?
Yes.
Okay.
The one that x plus y equal 39. And then the second equation is y equal 12x.
All right. So do I have it right on the screen?
Yes.
Okay. So now this one is actually sets you up for substitution because you have one of your variables already solved.
Mhm.
So we're good to go in that regard. So if you're talking about walking through the steps that I had set up, the first step was to solve one of your equations for one of your variables. This is already done for us. So we don't have to do anything with that regard. That's already done. And that was, if I call this one equation 1, that was equation 2. And the only reason I label them like that is because in the next step, you're supposed to use the other equation. So here we use the equation 2. In the next step, we start off with equation 1. And we're
Okay.
going to plug in what y is equal to. So we solve for y here. So we need to plug in what y is equal to right there. So that's going to be x plus 12x. And I don't need the parentheses, I'll leave it. Equal to 39. So that's your second step. You take what you solve for and then plug in what you have for that variable.
So, okay.
I'm listening. Mhm.
So does that you add the x so that turns into 13x?
You got it?
Okay, equal 39.
Mm-hmm.
And then divide by 13 on both sides?
Mm-hmm.
Okay. So x is equal to 3.
Mm-hmm.
Okay.
And then to finish it off, you take this equation from 1. You know that y is equal to 12x. So now you know what x is equal to. You plug it in, and that'll be 36. So your order pair is 336.
Okay. For some reason I thought that I was supposed to get 39 but they just happen to be close in number. I don't have to equal, I was trying to do something I didn't have to do.
Gotcha.
So, okay.
Mm-hmm.
Okay, so I'm working on the review now for the test, for
Mm-hmm.
test number 3. So, what I'm doing, I'm printing out the examples and then trying to do them according to the example. Is that okay?
Sure.
Okay. All right. Okay, I think I'm good. And I may have a question about grafting, but if we can, I know how to enlarge the screen now so that
Okay.
I can be more accurate with the grafting. Maybe
Okay.
because my eyes are old, but I have
Oh,
to
get out of here.
I have to really enlarge it.
Mhm.
So I'm doing better with the grafting. Okay, so if I were to graft this, then that would be a positive 3 and positive 36 if I were to graph it, correct?
Mhm.
Okay.
Yep. Mhm.
Okay, I'm good. That was the only one that kept me up last night.
Okay, sounds good. So, like I said, next class, if you have some questions, feel free to bring them. We're going to do that one section, and then I'll leave the whole room, leave that class
Okay.
open for whatever questions you guys have. So,
Okay, so I'm gonna get through the review, and then that way I'll have the questions all set.
all right, sounds like a plan.
Okay, thank you.
All right, thank you. Have a good one.
You're welcome.
The reason why I wanted to stay.
Let me
Oh.
cut off the recording. You know what I
Oh,
mean?
okay.
So, yeah, so just in